Okay, so here's our example. We want to decompose a given expression that has a repeated irreducible factor, quadratic factor, in the denominator. Okay, look at that numerator. 5 terms, but that's okay. So what we're going to do is look at the denominator now. You have a linear factor of x, so let's take that into account. That x is not repeated, and so we just have a one term with that. Then we have a quadratic factor, x squared plus 1, that is repeated. So first we'll just put it once, and then the next time we'll put it twice. Okay, so those are our 3 denominators. Now we go to write the numerators. So we're going to have a, just a constant because it's got to be a degree less than that linear denominator. But here we can have a bx plus c. And then here we can have a dx plus e. And we just keep using the letters of the alphabet, and we're not going to have more than 26 letters, so terms to account for. Okay, so that's the setup. It's really all in this setup. Now think about getting a common denominator. So what do you have to multiply by right here? X squared plus 1 squared, right? Okay. And you're doing that in the denominator as well. What do you have to multiply by here? Well, you need an x, and you need an x squared plus 1. So that one's going to be probably the tricky one right there. Too many parentheses. And then what do we need here? Well, we just need an x. So you're getting those common denominators. Now remember, the black part is what we're going to need at the end when we put a, b, c, d, and e in. So we're going to have to find a, b, c, d, and e. Okay, so let's start writing this out. Here's the numerator we want. And now it's going to be a times. I would like to take that x squared plus 1 and square it, okay? So I'm going to do that off to the side. You can think about it being x squared plus 1 times x squared plus 1. Or you can, however you want to square the binomial. But that's how it squares. And then what do we get here in the middle? Well, we're going to have bx plus c times, and then I'm going to multiply this part out. So that's going to be an x cubed plus x. I'm just distributing in here. You kind of have to be careful on that middle one because you have 3 things going on. You've got a binomial bx plus c, an x, just an x term, and then you've got the x squared plus 1. Now you could put the x in the front and do the 2 binomials and then distribute the x, but I didn't do it that way. I just multiplied x times x squared plus 1 for now. All right, now I want to double check my work because I don't want to make a mistake. But don't be surprised, we all make mistakes. So I'll distribute here dx squared plus ex. Okay, I still have more distributing to do. So ax to the 4th plus 2ax squared plus a plus, okay, now I've got to FOIL this. So that's going to be bx to the 4th plus bx squared plus cx cubed, and it doesn't matter what order they're in because we're going to move them around anyway, plus cx plus the dx squared plus ex. I hope you have a big piece of paper. Okay, so there's a lot here. Now we start the matching game. So x to the 4th. Well, I have ax to the 4th and bx to the 4th. So I'll just write it out. But what that means is 1, that's the coefficient on x to the 4th, equals a plus b. Now, we've had a lot of them where the first equation was like a plus b. That doesn't always happen, just so that you know. Okay, now we have an x cubed term. And then what do I have for x cubed terms? Do I just have the 1? That's very convenient. because what that means is 1 equals C. So we already know what C is. Great. All right. Let's take red. I'm running out of colors here. So I have an x squared. And then how many x squared terms do I have? I have a 2ax squared. I have a bx squared. And I have a dx squared. All right, so that's what I have. So 1 equals 2a plus b plus d. Okay. Any more colors? Let's try. Oh, that's not a color. I'll have to go with black. All right. I was saving that one, the black one, for the end, but it doesn't matter. So negative x, right, is equal to, now where are the x terms? I have a cx and I have an ex. So negative 1 equals c plus e. And then finally, I'll go back to green. I have 1 for the constant equals a, just equals a. Okay, so I didn't have any other constant terms. Okay, well, that's how it works out. Take your time on that part because you got to get them matched up correctly. We already know C and we already know A. So nice. Okay, that means I know what B is. If A was 1, then B must be 0. Okay, so I've got A, B, and C figured out. And then I can figure out D, 2 times, what was A? 1. Plus 0 plus D. So I'm getting 1 equals 2 plus D, or D equals negative 1. I think that's all I've got there. And then the last one. So I've got negative 1 equals C. I know C. 1 plus E. So E equals negative 2. So I've got all these pieces of the puzzle that I've figured out. Okay, now where was that original? Where was it? Okay, right there. See if I can remember it. So I had A over X plus BX plus C over, it was X squared plus 1. And then it was DX plus E over X squared plus 1 squared. So now I just have to put in the A, B, C, D, and E. Okay, what was A? 1. Okay, so 1 over X plus B was 0. Now when B is 0, that means that whole term's out. So I just need C, which I believe was 1. Yeah, C was 1. And then what was D? Negative 1, X. And then what was E? I think it's minus 2. Minus 2 over X squared plus 1 squared. Now, I would probably leave it this way, but I will show you. You could factor out a negative 1 from that last term. So you could write it like this. And they might, I wouldn't bother, but, you know, this is fine too. Okay, now, I'm going to look and see if I got it right, because if I did, this will be very exciting. Yay! They did, in the book, they put it this way. I think WebAssign would take it that way, but you can play around with that. But that's a long one. That's our last one, though, and I always find these problems kind of fun.